today, so yesterday, during yesterday's lesson or Tuesday's lesson, I can't remember when we last had maths, you were asked to take some notes on solving equations when you've got the letters on both sides instead of just on one. So we know how to do nice, easy equations where we've got the letters just on one side. For example, 2x takes 7 equals 5 or something like that. But now we're going to have to deal with them on both sides. So I'm going to talk you through, everyone's been given questions from 4 to 8. If you're doing red cup, orange cup, green cup, you have slightly different questions to answer. I'm going to go through a few examples for question 4, 5, 6, 7, and 8. You're welcome to write notes as we go, but as soon as we finish this Zoom, I'm going to send out the recording of this Zoom as well as these notes to everybody by email. If you don't want to be in the recording, could you please turn off your video now? And I'd like everyone to mute themselves. If you have a question, please unmute yourself and then ask. Or if I pick on you to answer something, please unmute yourself and then answer. So we have question 14, has 10f plus 3 equals 23 plus 6f. So the problem with this question is that we have 10f here and we have 6f here. And we like to solve equations when we just have the f on one side. So what I'm going to do is I'm going to pick the side with the larger f, and the larger f out of side of these two. But what's larger between 10 and 6? It's 10. And I'm going to move the other one over to that side. So I've got to move the 6f over. How do I move a plus 6f? I minus it. So I'm going to write a little minus 6f under both sides. And then I'm going to write my next line of working out. Now the plus 3 and the 23 haven't changed at all. But the 6f has disappeared from this side, like there's nothing else there. And now I have 10f minus 6f. And 10f minus 6f is 4f. So now I've got 4f plus 3 equals 23, and now it's exactly like what we've been solving. We know how to do these. We're going to start off by minusing. So we end up with 4f equals 20, and then we're going to divide. So we're going to have f equals 5. The one next to it's really similar. I think we're going to run out of time this Zoom, so I'm just going to go straight to f. The reason I've chosen to go straight to question f is because we've got 3n here, and we've got 10n on the other side. So we're used to putting things over to the left to seeing, you know, whatever x equals whatever, but it doesn't have to be that way. Now, because 10 is bigger than 3, I'm going to get them both over to the right, which means I'm going to subtract 3n from both sides. So my next line of working out, the 4 is still there, and the plus 39 is still there, but the 3n take 3n, there's no 3n on the left anymore, and 10n minus 7n equals, 10n minus 3n equals 7n. Now this is how we're used to seeing things, except normally we're used to seeing 7n plus 39 equals 4. And you're welcome to write it around that way, like that it's exactly the same thing, but you don't need to. You can keep it like it is. We know we have to subtract 39 first. So we end up with 7n on the right-hand side, and 4 minus 39 is negative 35. And then we're going to divide by 7 after that. So we end up with n and negative 5. So n equals negative 5, and you're welcome to leave it that way around. Question 5 is pretty much the same. I'm assuming we're just going to get some weirder answers. But we start off by looking at the pronumerals. So we've got 8t on the left, 2t on the right. 8's bigger than 2. So I'm going to move the 2t over to the left. So I'm going to minus 2t. So that's just, if there's no sign in front of it, you assume it's a positive because that's what we've chosen not to write in maths. Mathematicians are always lazy. There's always something you don't have to write. So we're going to minus 2t. So we've got our minus 24 still there, minus 6 is still there, but these have disappeared, and 8t minus 2t, well, that's 6t. And now we deal with it like normal. We're going to plus 24. So we end up with 6t equals negative 6 plus 24, 18. And we're going to divide by 6. So 18 divided by 6 is 3. This question's really similar. So let's have a look. 2c and 4c. 4c is bigger than 2c, so I'm going to get everything over to the right. So I'm going to minus 2c. I just noticed that Will Boyle has a picture of, is it Beaker? No, Bunsen in his picture that shows up when he's not on the screen. Okay, so we're minusing 2c, which means we've still got the minus 2, and we've still got the minus 6, but the 2c minus 2c, that's disappeared. And the 4c minus 2c, well, 4 minus 2 is 2, so we've got 2c. Our next step, as usual, get rid of whatever's plussed and minused. So we're going to plus that 6 to get rid of it. So we've still got 2c on the right. On the left, we've got negative 2 plus 6, 4. And then we're going to divide by whatever's in front of the letter. So we end up with c, and we end up with 2. So they're not too bad. Question 7, bit weird. We've got 2k here, and we've got 5k here. So we're going to minus 2k to get it to, because it's smaller than 5k. So on the left-hand side, we've got this minus 2. On the right-hand side, we don't have anything. When we don't have anything, we write 0. And that 5k minus 2k, that's 3k. And now again, this is what we know how to do with already. Plus 2, we get 3k equals 0 plus 2 is 2. Divide by 3, we get k equals 2/3. I'd rather you left it as a fraction instead of a decimal. If you did it on your calculator, press S to D. Okay. Now this one has minus j and this one has plus j. So what we're going to do, well, negative 1, remember if there's nothing in front of it, it's like there's a 1 in front of it. What we're going to do is we're going to move that minus 1j over to the right. So because what positive 1's bigger than negative 1, yeah? So we're going to plus 1j to both sides. We've still got this 3 here, and we've still got this 4. The minus 1j and plus 1j, they've cancelled out. And plus 1j plus 1j, like 1 plus 1 is 2. So we get 2j on the right. And now we know how to deal with this. We need to get rid of this 4 first. So we're going to minus 4 from both sides. So we've got 2j on the right-hand side. I mean, that plus is still there, but we don't bother writing it now. And that 3 minus 4, negative 1. So now we need to divide by 2. So we get j equals negative 1 over 2. Question 8, I believe only the green cup. So if you're pretty confident with the other stuff I've just worked through, you'll be facing this question. And essentially what it wants you to do is write an equation. They've given you an equation in words and they want you to actually write it mathematically and solve it. So I'm just going to go through A for you now. And you're going to have to go through the rest of yourself. So they're saying doubling x and adding 3 is the same as tripling x and adding 1. Well, what do they mean by doubling x? Doubling x is timesing by 2, isn't it? And then they're saying adding 3. So plus 3. And then they're saying is the same. Whenever they say is the same, that's the equal sign. And then tripling x is x times 3. And adding 1 plus 1. Now, we wouldn't write it like this in maths. We would write 2x plus 3 equals 3x plus 1. Now you want to solve it as usual. We've got 3x here, 2x here. 2x is smaller than 3x, so we're going to move it. So we're going to minus 2x minus 2x. On the right left-hand side, we've still got this plus 3, although we don't usually write plus when it's on its own. And then we've still got this plus 1. 3x take 2x is 1x, but we don't usually write the 1. And now this is even easier than usual, because all we have to do is minus 1, and we've got x on its own. So all of those questions, you're just going to figure out how to write them mathematically and then solve them as usual. So that's kind of a quick run through all of the questions that you'll be facing. Oh, I haven't asked you to do 6. That's why I didn't bother with these. Does anyone have any questions? Or if you're a bit confused, would you like me to go through this extra ones for question 4 or 5? Unmute yourself and say now. Anyone? No one? Everyone's feeling good? It's just a matter of working through it slowly and not expecting to get it all at once. You are going to have to do at least, 3 or 4 lines of working out for each of these. So if you just keep your working out the same each time and try and follow the same setting out as I've used, then it should be fairly simple, yeah? No worries. Tex has got his thumbs up. Anyone else? Oh, okay. I just interpreted Tex's, he's recorded a background.
I had one earlier, but no.
Anyone? All right.
Planes.
Thank you very much for joining. And you'll have to work through these textbook questions today. And you'll also have tomorrow's lesson to work through them as well. So don't stress if you don't get them finished today. And tomorrow, if you finish them and you've still got time, I'd like you to finish off anything else on Math Space that you've got coming up. And then
No, I'd like a birthday A.
A birthday A?
Yeah.
No. Sorry. But when's your birthday? Oh, he's left.
On the 10th.
On the 10th. Happy birthday for the 10th. That's exciting. And it's on the Sunday, so you get the day off. I'm giving you the day off. You're welcome. Thanks very much, everyone, and I'll see you next week. Please email me if you get stuck.